Alright, so today we're going to be starting solving exponential equations. The one that we're going to finish with is this equation up here. 4 to the x plus 3 equals 2, 8 to the 2x minus 1. Now these are going to be very unique and special because there's always going to be a common base that we can find to rewrite this equation before solving. So first let's talk about what is a common base. I gave you three numbers, 2, 8, and 32. Now each of these numbers can be rewritten to have the base of 2. 2 is 2 to the power of 1, 8 is 2 to the power of 3, and 32 is 2 to the power of 5. So now each of these three numbers have a common base of 2 with their own respective exponents. So let's use that skill to solve this equation. So I have 2 to the 3x plus 1 equals 4 to the x plus 2. What I'm claiming is that there is a number that can go in for x to make this side equal to that side. So the first thing I do is I change so I have common bases. In this case, 2 is already 2 to the 1, but 4 can be 2 squared. So now here, I'm going to distribute the 2 to the other two exponents. So I get 2x plus 4. Now that I have common bases, 2 to the power of something is the same thing as 2 to the power of something. Well, if you think about that, if they both have the same base, therefore, the exponents must also be the same in order for them to be equal. So I set up an exponential equation. And then I solved. So I'm claiming that if x equaled 3, that the left side would be equal to the right side. So we can test it. Plug in 3, I get 2 to the 10th is equal to 4 to the 5th. 2 to the 10th is 1024. 4 to the 5th is the same thing. Now let's take a look at the example from the beginning. I can rewrite 4 to being 2 squared and 8 to being 2 cubed. So I do that, same basis, distribute the 2, distribute the 3, I get this exponential equation, I get x is 9/4. If common bases cannot be found, we cannot solve them without logarithms. Smiley face, because we'll be getting into that. I test it, and I get that 1,448 and 15/100 is about the same as the other number, so we're good. Two problems I'd like you to try. They're pretty straightforward. Tomorrow I'll give you ones that are a little more complicated. Good luck.